Hello and welcome. Today we are going to talk about linear equations. We have several objectives. We're going to solve several types of linear equations, starting with the most simple of them. And we are going to learn to show our work in the ways that make the most sense. In some cases, we're going to learn several ways to show our work. We want to pick the best one. We're going to observe the correct order of operations as we solve these linear equations. And we're going to check our work in most cases. Some of the vocabulary terms that we're going to discuss today: variable, coefficient, like terms, reciprocal. I'm not going to give you a definition of these. I'm going to give you examples. So the variable is the letter usually that we use in place of a number. We don't know the number of the value, so x is the most common variable. The coefficient is that number that goes in front of the variable, meaning we multiply the two together. So this means 7 times x, and that's why it's underlined. Like terms, 7x and negative 2x are like terms because they are followed by the same variable. That means we can take these coefficients, the 7 and the negative 2, we can add them together, in which case we get 5. But we can only do that because these are both x's. If one were a y, they would not be like terms. We would not be able to do that. And then reciprocals. That's when you take a fraction and you flip it upside down. The reason we do that? To multiply them together and get a positive 1. This is a simple example. There are more complicated examples of reciprocals, but again, we want to multiply them together and get a positive 1. This one we could do in our heads if we wanted to. 2 plus x equals 5. Well, we know that a number plus 2 is going to equal 5. We know in our heads that that's going to be 3. But let's take that apart a little bit so we know the process for doing this when it becomes more complicated. So we want to get the x by itself, and the x is already on the left side, so let's make sure that the x stays on the left side. We're going to do the opposite of plus 2. There's an imaginary plus there. Opposite of plus 2 is minus 2. I'm going to draw it right below it. And then if I do it on this side of the equation, I have to do it on this side. So I'm going to subtract 2 from this side as well. And I'm not going to put the equal sign there because I'm doing a different kind of little function here. So we know that these are going to cancel out. Those are going to cancel, and it's going to leave the x by itself on the left side of the equation. And the 5 minus 2, or we could say 5 plus a negative 2, is going to give us the 3. So we knew we were going to get that number, but I wanted to show you how I'm going to notate it. The negative 2 on this side and the negative 2 on that side. Okay, we're going to get a little more complicated. We're going to look at x. We're going to get the right tool. Brushes. We're going to look at x minus 1.5 equals 4. Right, we have x on the left side, which is kind of where we want it. We don't have to have it there, but it's easier for me to remember it that way. We have minus 1.5 or plus a negative 1.5. So the opposite of that is plus 1.5. Got to do it to the other side as well. Got to have that little plus sign in there. Okay, so we know that these are going to cancel. We're going to get rid of those. I meant to do that in red. It's okay. Then we have x by itself. And then we have 4 plus 1.5 over here. We know it's going to be 5.5. So again, in our heads, we know that that's going to be the right answer. But we wanted to look at a different function. The opposite of subtract is to add. And we wanted to see that sometimes we don't have whole numbers. Sometimes we have decimals and fractions that we have to deal with. So x equals 5.5. Okay, let's get a little bit more complicated. We're going to, well, it's not even that much more complicated. Wrong tool. We're going to just look at multiplication. What happens when we multiply? So 3x equals 18. Now we know that when we have a number right next to a variable like that, we're multiplying them. 3x's basically. 3x's walk into a bar. No. 3x's equal. So we know that something times 3 is going to equal 18. We know in our heads that's going to be 6. We know that's the answer. But let's look at how we're going to notate it for when it gets more complicated. So we're going to do the opposite of times, which is divide. Opposite of multiply, I should say. So instead of multiplying by 3, we're going to divide by 3. Got to do it to the other side as well. And I have to do it to the whole side of the equation. And neither side is very big, but sometimes they are. So that's important to remember. So now we're going to cancel. We have the 3 on the top and we have the 3 on the bottom. We can cancel them. We know that's going to leave x. 18 divided by 3, we know it's going to give us 6. But now we know how to notate it. There's something important going on here, and that is reciprocals. So we have to study reciprocals for just a little bit. 3 we could also write as 3 over 1. And we want to multiply that by its reciprocal. Its reciprocal is just the same thing turned upside down. And this is a review. We should know what reciprocals are. But basically when we cross multiply, we get 3 on the top, we get 3 on the bottom. Well, the number over itself, as long as it's not 0 or something else weird, is going to give us 1. And that's important. Positive 1. That's what the reciprocal does. We multiply a number by its reciprocal, we get positive 1. That's what we did over here. When we multiplied by 3 and then divided by 3, it does the same thing. It makes that 1, positive 1. So we're going to look at it just a little bit different. It's going to give us the same result, but we're going to look at it just a little bit different. So 3x, wrong tool, 3x equals 18. So we're going to multiply by the reciprocal of 3. Remember, 3 can be written as 3 over 1. We can think of it that way. The reciprocal of 3 over 1 is 1 over 3. And then 1 over 3 here as well. So we're going to find a third of 3. Well, that's easy. It's 1. A third of 18. If we had 18 apples, we've got to split it 3 ways. Everybody gets 6. So x equals 6. So the other way that we did it is probably the better way to do it. But we need to know about reciprocals for when we have fractions. And the next one we have is a fraction. So now we have a better idea what we're doing. Control A, delete, get the right tool. Okay, the one that is a fraction it's negative now. 2 over 3 x equals 4 over 9. Okay, so we want x by itself. We have to multiply negative 2 times 3 times a number to make it positive 1. Well, we're going to flip it over because that's the reciprocal. But this is important. The reciprocal needs to make the original number a positive 1. Well, in this case, it would be negative because a negative times a positive is going to give us a negative 1. We don't want that. Control Z. So we need to make this negative as well. So the reciprocal of this negative number is also negative. That will give us a positive 1. Okay, so let's write that again. Negative 3 over 2 times negative 2 over 3 x equals 4 over 9. Got to do the same thing to the other side. So we're multiplying this times negative 3 halves. This is also going to be a negative 3 halves. Okay, we know that those are going to cancel. Get rid of, I'm going to do it in red. I'm determined. Those are going to cancel out and just leave us with x over there. And then over here, this negative sign, it could go with the 3 or the 2. I like to say that it goes with the top number because I see it that way more often. So we're going to say that this is a 4 times a negative 3. And so that would give us a negative 12. And the negative 1 up there, it does not have to go down here now. So 9 times 2, 18. And we are almost there.
problem is we have to reduce.
Now we need to reduce negative 12 over 18. So let's look at the factors that divide both of them. Well, negative 12 can be divided by 2, it can be divided by 3, 4, and 6. 18 can also be divided by 2, it can be divided by 3, not 4, but it can be divided by 6. Well, the highest number in both cases that match is 6. So we can divide the negative 12 by 6, and when we do that, we get negative 2. And we could divide the positive 18 by the 6, and then we get positive 3. So that reduces quite a bit in this case.
Let's plug that in to make sure that that is right. Let's get rid of this. I'm looking at my notes here and I'm looking at them wrong. That's why I'm messing it up. Okay, so we're going to plug in the x to make sure that that's right. So we have x here. We determined that x has to be negative 2 over 3, so we're just going to plug it in. And we're going to see if that gives us 4 over 9. That's what messed me up right there. Okay, so negative 2 times negative 2 gives us 4. 3 times 3 gives us 9. Yes, that is a true statement. 4 over 9 equals 4 over 9. So we know we have the right answer. We just had to take a bumpy road to get there. Okay, we're ready to move on to something a little more complicated, but in the same style. Make sure we have the right brush here. This is going to be negative 3/4 times x gives us 12 over 20. Okay, so we need to get the x by itself. We're multiplying it times negative 3 over 4. What's the reciprocal of negative 3 over 4? It's going to be negative 4 over 3 times negative 3 over 4. We know there's going to cancel out. The important part is we do it on the other side. Times negative 4 over 3. Okay, so we know that those are going to cancel out. Going to leave us with x. Okay, and then we multiply across the tops when we multiply the fraction. So here is the issue. You might remember this from pre-algebra, earlier math. This is going to give us kind of a high number, and we want to reduce this number if we can. So we're going to cross-cancel. That's what I like to call it. We're going to cross-cancel while we can. So we have a 12 over here, we have a 3 over here. Well, they are both multiples of 3. So 3 divided by 3 is 1 over here. And then 12 divided by 3 is 4. Okay, we have the 20 and we have the 4. So the greatest, what is it called? The greatest common divisor of those, the number that can divide them that's the highest, is 4. So 4 divided by 4 is going to give us 1. 20 divided by 4 is going to give us 5. Now that's going to make it a little bit simpler for us. So now we have 4 times negative 1, negative 4, and we have 5 times 1. We have negative 4 over 5x equals that. Let's check it though. Let's plug it in. So we know x equals that. We're going to plug it in for x. Make sure that that equals 12 over 20. Okay, so the negative 3 times the negative 4 does give us positive 12. 4 times 5 gives us 20. Yeah, looks like it's the same. We don't even have to pull it down. 12 over 20 equals 12 over 20. Okay, so some of you probably noticed that there is a time-saving step we could have done. So let's look at that again and do it with the time-saving step that we could do. Okay. It doesn't save us a lot of time, but it saves us a little bit of time. -3/4. That fraction is reduced. 3/4 is a reduced fraction. 12/20 is not a reduced fraction. So we ran into reducing trouble a little bit before. We're going to do it right this time. So what is the highest number that will divide both of them? Well, in this case, it's 4. 12 divided by 4 will give us 3. 20 divided by 4 will give us 5. Is that right? Yeah. 3/5. Okay. So that's gone. We'll get rid of that. And this is our new equation. And we're going to get x by itself, so we need to do the reciprocal again. -4/3 x. No. Control-Z. Times -3/4 x. The times sign. It should equal 3/5. Gonna make sure it does. Okay, those are going to cancel. And we got to do it over here too. -4/3. Okay, those are going to cancel. Then when we multiply the tops, 3 times 4 is going to give us -12. And then the bottom is going to give us 15. Okay, those can reduce because both of those are divisible by what number? -3. So we're going to divide the top by -3, or just really +3 in this case. And that's going to give us -4. 12 divided by -12 divided by 3 is going to give us -4. 15 divided by 3 is going to give us 5. So we have the same answer. X is going to equal -4/5. And we can plug it in and we can check it, but we kind of did that before, so we know that that's going to be the right answer. Okay, we're ready to move on to the next idea. Number 4. Okay, this is when we have to multiply and add in the same problem, or if we have to divide and subtract in the same problem. We have to do two things to get that x by itself. We have to do two functions. 2x plus 4 equals -2. So to get that x by itself, we have to get rid of the plus 4. We also have to get rid of the times 2. We have to get rid of both of those. Which one do we get rid of first? If we want to think about it that way. This is the one we want to get rid of first. We want to deal with the addition and subtraction first. We want to get rid of those first. And I will explain why a little bit later. So we're going to do the opposite of plus 4. We're going to do -4. Got to do it on both sides. And we know those are going to cancel. That's going to leave us with 2x. Okay, I was $2 in debt. Now I'm $4 more in debt. I owe a lot of money. I'm -6. Okay, so 2 times x equals -6. Now we want to get rid of the times 2. So the opposite of multiplication is going to be division. We're going to divide that by 2. We're going to divide that by 2. Those are going to get rid of each other, cancel out, and then we're going to have x equals -6 divided by 2. -6 divided by 2 is going to be a -3. A negative divided by a positive is going to be a negative. So we have x equals -3. We've got to make sure that that is right. We're going to check it out. We're going to plug it in. This time I'm going to use parentheses instead of that little dot. I'm going to plug x in for the value that we think it is. See if it's a true statement. Okay, so we have 2 times -3 should give us -6 plus 4 gives us a -2. Well, I think that's right, because -6 goes to war with +4. The negative wins. It's -2 equals -2. That is a true statement. So that is correct. Okay, so that one wasn't too bad. Let's move on to one where we have functions on both sides. So we have 2 plus x equals 2x minus 3. So we have issues on both sides. We have addition over here, and we have multiplication and subtraction over here. But we're going to make it a little simpler in our heads, and we're going to combine a step. And that's why I'm showing you this one, so we can see combining a step. I like to get the x's on this side, the variables. It's not always an x. And I like to get the regular old numbers on this side, on the right side. That way the end will be x equals something. So we'll get the x's over here, the regular numbers over here. We don't have to do it that way. Sometimes it's easier not to. Just in this case, I think that's going to serve us better. Okay, so to get rid of the positive 2x, we're going to subtract 2x from this side. And that will get rid of the x's over here. We have to do it over here as well. And we want to remember too that there is an imaginary 1 there all the time, so that we know that we are subtracting -2 from a positive 1. Okay, so if we want to get rid of the regular old numbers over here, there's only one. It's a +2. So we want to subtract 2 from this side, and we know that that's going to cancel. Got to do it over here as well. Got to subtract 2. So we're combining the steps, and hopefully that will simplify. Okay, we know what we're going to get rid of. Those are going to cancel each other out. Positive 2x and the -2x. And we know that the +2 and the -2 are going to cancel each other out. Okay, over here we have 1x and a 2x. So they go to battle, and it becomes a -1x. But really we don't need that -1. We just need the negative. So let's get rid of the 1. -x equals, over here, I was $3 in debt. Now I'm $2 more in debt. I am -5 in debt. Okay, got to get x by itself. We got to get rid of that negative sign. Well, there are several ways of looking at that. This term is negative, this term is negative. We can just make them both positive. That's just a little trick that we can do. And that's the shortcut version that I have in my head. There's the rule that we're really doing, Control Z. We could say that we're multiplying times a -1. We're doing that to both sides. And all we're doing is canceling the signs by doing that. So this negative cancels that one, this negative cancels that one. Still we have x equals 5. Okay, we're going to check it. We're going to plug it into our original equation and make sure that it works. Okay, so our original equation is up here. 2 plus 1 times 5. Oh, my handwriting's getting pretty awful. 2 times 5 minus 3. We're going to make sure this balances. So the order of operations, if we're just looking at this side, we're going to do just this side. Order of operations tells us that we have to multiply first, and then we can add. So we're going to multiply the 1 times 5, we get 5. 5 plus 2 is going to give us 7. Let's see if we get 7 on the other side. Order of operations tells us we have to do this first. 2 times 5 is 10, minus the 3. 10 minus 3 will give us 7. 7 equals 7. That one's good to go. Okay. That was our number 4. We're going to move on to another one that's similar so that we can practice that. Did we just do that one? We just did that one. We're good to go. Okay. So we're going to do this one. When they're fractions, they get a little bit more complicated. 3 over 4 minus 1/3 x equals 1/4. Okay, so we want to get the x by itself. We have to get rid of this positive 3/4. So we're going to add 3/4, or sorry, it's not the opposite function. We're going to subtract 3/4 from this side. We're going to subtract 3/4 from this side. So we know that those are going to cancel. We're going to be left with negative 1/3 x over here. And now we have 1/4 minus 3/4. Well, the rule for adding and subtracting fractions, the bottom numbers have to be the same. If they weren't the same, we'd have to do a little operating to make them the same. But in this case, they are the same. So all we have to worry about is the top. We have a 1 minus 3. Well, 1 minus 3 is going to give us a negative 2. And then the bottom number just carries down. Negative 2 over 4, we know that that is going to reduce. So let's go ahead and reduce that. I did it again. Okay. We know that's going to give us a negative 1/2. Okay, so a negative 1/3 times x equals a negative 1/2. We still have to get that x by itself. We have a negative 1/3 over here. What's the reciprocal of negative 1/3? Well, it is a 3 over 1. Well, 3 over 1 is just 3. So we know we're going to multiply this times 3. But wait, this is negative. So if we want to multiply times a number that's going to make it a positive 1, it's going to have to be a negative 3. So the reciprocal of negative 1/3 is negative 3. Over here we have to do the same thing. We're going to multiply, I don't want to do it that way. I prefer this way. That makes more sense to me. So we're going to multiply both sides times a negative 3. Okay, so we know that those are going to cancel out. X will be left by itself. We'll have negative 1/2 times negative 3. Well, now I am going to do it this way because that's easier for me to remember multiplying. We have a negative 1 times a negative 3 is 3. So we do the tops, and then we can do the bottom. 2 times negative 1, or 2 times positive 1. The negative's up there. 2 times positive 1 will give us 2. So we have an improper fraction. A lot of times that's going to be okay. The instructions might tell you to write it as a proper fraction, or a mixed number, and not as an improper fraction. So we know that if we had 3 halves, if I had 3 halves of an apple, what I really have is 1½ apples, or 1½ cups of water, whatever it is. We won't go through the process of making a improper fraction into a mixed number, but it just depends on how we have to do it. Okay, but we do need to check it though. So let's get rid of this. And we're going to put in 3 over 2 as x, and we're going to put it back up here. Okay, so when we plug it in, make sure I have the brush. Okay, 3 over 4 minus 1/3 of 3 over 2 should give us 1 over 4. Plugged in this number for x. Let's see if it balances. Okay, order of operations tells us that we have to do this first. We have to do the multiplying first. So we just carry this down. We're going to multiply the top 3, multiply the bottom 6, equals 1/4. Oh, now we have to deal with changing these so that we can subtract this fraction from this fraction. You have to have the same denominator at the bottom. So let's go ahead and review that. The common factor between those would be 12. Because 4 times 3 is 12. 6 times 2 is 12. Okay, so to make the 4 into the 12, we had to multiply times 3. We have to do that to the top as well. That becomes a 9. 3 times 3 is 9. We have to do that over here as well, but it's a different number, and that's where it gets tricky. That's why adding and subtracting fractions, you really have to be watching what you're doing. So to make the 6 into 12, we had to multiply times 2. We have to take that 6. We have to multiply it times, or 3, multiply it times 2. Got ahead of myself. It is 6. Okay, now we can subtract the 6 from the 9. And that gives us 3 over 12. If we reduce 3 over 12, does it become 1/4? Yes, it does. That's not right. 3 divided by 3 is 1. 12 divided by 3 is 4. So we know that that is a true statement. All right, that is our 6th problem. That concludes it for today. If you have any questions, I might have questions for you, actually. But if you have any questions, please let me know.